Welcome to One Question at a Time, the SAT series. Question number 20. Solve for x given 2 to the power of x plus 2 to the power of x plus 2 to the power of x plus 2 to the power of x equal 2 to the power of 7. So to approach this question, we will have to review on if we have x plus x, that 2x, right? Plus one more x plus another x. What's that? We count on the term which is the same term, right? X. 4 times. So it's 4x. Now here we have 4 2 to the power of x. That's the same term, right? So we count on it. We have 4 times 2 to the power of x. That equal 2 to the power of 7. Two to the power of x, 2 to the power of x, 2 to the power of x, one more, that's 4 total. And we should remember that 4 is 2 to the power of 2. Here we have two ways to approach these questions. The first one, we can use the formulas at if we have the base a to the power of m, we divide to a to the power of n. That will be equal a to the power of m minus n. So here, why we have to convert everything to the power of 2? Because as we see, all the terms have the base 2, right? So it's easier if we convert everything in the same base, and in this case it's 2 base of 2, okay? So let's write down the first way. We will have 2 to the power of 2 times 2 to the power of x, that equals 2 to the power of 7. Now we solve for 2 to the power of x, so we want to isolate this one, right? So write that down. We divide both sides by 2 to the power of 2. And this one is 1, right? 1 multiplied by 2 to the power of x, that's just 2 to the power of x, equal, we apply the formula which is reviewed on the right side. So m is the power at the top, subtract the power at the bottom. So we have 2 to the power of x is equal to 2 to the power of 5. So x equal 5. D is the right answer, right? How about the second method? We will apply another formula. Okay, we have a to the power of m. We multiply by a to the power of n. That will be equal a to the power of m plus n. Okay, so how we do this? We will rewrite 4 as 2 to the power of 2. That's 4. We multiply by 2 to the power of x, that equal 2 to the power of 7, right? But now we know that we have the same base with the multiplication, right? So that will be 2 plus x. My m in this case is 2, and then my n is x, right? That equal 2 to the power of 7. Now you see that we have the same base of 2. The power should be the same, right? So 2 at x, that equals 7. Now we solve for x. So we subtract both sides by 2. Then we have x equal 5. This one cancel. So anyway, any method, we will have the same answer. And to explain how we have those formula, right? It's kind of easy. Let's start with the first formula. So for example, in this case, we have 2 to the power of 7, right? 2 to the power of 7, that equals 2 times 2 times 2 and times 2. We need 7 of the factor of 2, right? Then you will divide by 2 to the power of 2, which is 4, right? So we divide it 2 times 2. So when we cancelations the factor of the common factor from top and bottom, we cross this out, right? At the bottom is always have 1, right? So this one now, look at that. We can count again. How many factor of 2 do we have at the bottom? I mean at the top. So we have 1, 2, 3, 4, 5. Right? We have 5 factor of 2, which is 2 to the power of 5. Okay? So how about the second one? Let's explain the second one. So we have 2 to the power of 2, right? If we multiply by 2 to the power of 5 in this case, 2 to the power of 2, you have 2 factor of 2. Then you multiply 5 more factor of 2. So now we can count on that, right? 1, 2, 3, 4, 5, 6, 7. So that equals 2 to the power of 7. That makes sense? So when you multiply, you're adding the power. When you divide, you will subtract the power. The most common mistake here is we have one more formula, which is people mostly will be mistake with this one. This is a to the power of m to the power of n. That different, okay? This will be a to the power of m multiplied by n. Power of power is multiplications. Product will be additions. Remember that, okay? Thank you for participating in this series. See you next time.